All right, this is the worksheet I had each of you complete, and I'm going to make sure that we have a chance to go over it together. So by going over it together, I can make sure you have this available, and I'll just walk you through how to do it. So what we're looking at here is we are looking at the subtractive color process, and we're also kind of using the additive color process. So I draw the color wheel, and I even use this myself. I've got red, green, and blue are my secondary colors in the subtractive process, and I have yellow, cyan, and magenta are my primary colors in the secondary process, whereas red, green, and blue are my primary colors in the additive process, and my yellow, cyan, and magenta are the secondary colors in the additive process. But I need to make sure I'm separating which process I'm using. So if I look at my first example here, so I have red, green, and blue light. Well, that's another way of saying that's white light. And I have white paper. So I'm going to have white light reflecting back off of it. So when I look at this, what color is absorbed? Well, there's none. There's no color absorbed. I've got red, green, and blue colors reflected, and that is what I view as white light. So looking at letter B, I have yellow. Yellow, I know, I can look at this in my color wheel, and I'll just reference you to this for a little while. I won't do it every time, but you'll start seeing a pattern. I've got red and I've got green. So I know that yellow is both red and green, R and G. And I have white light. Well, see, white light is red and green, white paper, red and green and blue. That means that red and green are going to be reflected off of it. So what color do we see? Well, we see the colors red and green reflected, so therefore we see that as yellow. So, moving on to letter C, I've got cyan light. Cyan is both blue and green. Oh, here I wrote green and blue. It doesn't matter the order. In this case, I've got white paper. White paper is R, G, and B. So nothing or none are going to be absorbed. I've got green and blue colors that are going to be reflected, blue and green, and I view this as cyan, and that's why I have cyan here. So here I can look at letter D. I have red, green, and blue light, so that's the same as white. I have, in this case here, I've got red, right? I only have red paper. So red in this case is going to not only be reflected, I can also say that the green and the blue, so white light, the green and the blue are going to be absorbed. And I view the color, I only see red that's reflected, so red is the color that I see. Looking at letter E, I have yellow light. I have yellow light shining onto red paper. So yellow is going to be red and green. What letter am I on? E here. So yellow is red and green. Okay, I've got red paper here. Well, remember, if in this case here, it's going to absorb the green. So green is going to be absorbed, and I'm going to have red reflected off of it. Letter F, I've got cyan light. Here I've got blue and green light. Right, cyan is blue and green. Once again, I'll come point you back down here to my color wheel. Blue and green. Light goes together to make cyan. I have red paper. So when I look at F, let's see, colors absorbed. Red is going to absorb both blue and green. So let's look at that for a second. Red is going to absorb its complement of cyan. Cyan is composed of blue and green. So notice green and blue are both going to be absorbed, right? Absorbed here. And therefore no color is going to be reflected. Where am I here? None. And therefore we view that as black. Black is the lack of color. Letter G, red, green, and blue light. I have white light here shining onto yellow paper. In this case here, I know that yellow, remember, yellow is going to be red and green. So I've got red and green. So I'm looking up here. Oops, right there. And therefore, let's see, I've got red and green are going to be able to be reflected, but blue is going to be absorbed. So I've got G here, I've got blue absorbed, I've got red and green reflected. The red and green that's reflected, I view, or I see, as yellow. Letter H, I've got, let's see, yellow light. So yellow light we've determined is red and green. And I can look at my color wheel, or I can use a prior problem over here. There's a lot of ways I can go about this. And I've got yellow paper. Right, still red and green, and therefore red and green is going to be reflected. So when I look at H, nothing is going to be absorbed, and therefore red and green are both going to be reflected, and we view red and green as yellow. So yellow light shining on yellow paper is going to reflect the color yellow. And last but not least, cyan. Cyan is going to be composed of blue and green, and I've got it shining on yellow paper. Remember, yellow is going to be red and green. So let's see. If I look at what's going to be reflected, I can kind of say, well, what does it share? It shares green. So green is going to be reflected. And therefore, if green is reflected from the original light coming in, blue must be absorbed. So therefore, what is absorbed? Well, blue is absorbed. Green is reflected. Therefore, I see green color. Now, if I flip this over onto your other side of the handout that I had you working on, back to working on filters. So now I can say, so let's look at this practice problem here. And you know, you can keep a color wheel handy, or if you still need it. Otherwise, you probably want to get used to the color wheel itself, both additive and subtractive. And they're really kind of the same. Just remember that additive, they light add together, complements create white, whereas black complements create or generate black, which is the lack of color, because it's absorbing all colors. Okay, letter A. Practice A. If I have red and blue here, well, red and blue, you should be able to see this is magenta. So the color of the light, oh, here we go, down at the bottom. The color of the light itself is magenta. The color of the filter is provided here as cyan. So I've got it down here. So if you can follow this down here. Cyan, I've got magenta light. Well, let's see. I know that cyan is composed of blue and green, and I know that magenta, I've got red and blue coming in. Well, let's see. That means that blue is going to be transmitted, right? So I've got red and blue. Well, this blue filter is going to allow blue through, and it's going to absorb the red. So I have, well, what color is transmitted? I have blue. What color is absorbed? Well, here I have red. So let's do practice B. So I've got red and blue, and you should know by now red and blue. I've got magenta light. So if I look down here at the bottom, I've got magenta light. And in this case here, I have a filter. It's labeled Y, so it's going to be yellow light. And in this case here, I have, well, what color is transmitted? So let's look at what yellow is. Remember, yellow is both red and green, and I have red and blue coming in. So let's see. Red, well, a yellow filter is going to allow red and green through. Well, that means red is going to be transmitted, right? Red is going to be transmitted. Blue is going to be absorbed. And that should be consistent with my answers down here. Red is going to be transmitted, blue is going to be absorbed. Letter C. Letter C. If I look at this, I have red and blue light, right? Red and blue, we've determined, still magenta. And I have a magenta filter. Well, let's see. It's going to allow red and blue through. So I'm going to actually have, let's see, red and blue light. Red and blue, I've got magenta. I've got a magenta filter. Letter C. Oh, sorry, I skipped one on you. Magenta color filter, a magenta color of light. Magenta is transmitted. I think I said that. And nothing is absorbed. Sorry, I had skipped one when I was talking that out. Letter D. Letter D, I have white light. I have a cyan filter. Remember, cyan is blue and green. So let's see. So based on here, let's see, letter D. There we go. Now I'm correct. I've got white light. I have a cyan filter. Right, once again, just going back over this, blue and green. Cyan is composed of blue and green. So therefore, cyan is going to be transmitted, right? Both blue and green are transmitted, but those colors together we view as cyan. And therefore red, right, I've got red, green, and blue coming in. Well, red doesn't make it through the filter, so red is what is absorbed. Bingo. Letter E, I have blue and green. By now, blue and green, you should know, is cyan. Is a color of light. So let's see here. So I have cyan light, right here. I have a yellow filter, it's labeled in the picture. And here my yellow I know is red and green. Let's see, so cyan is blue and green, so that means green is going to be transmitted and blue is going to be absorbed. Green is transmitted, blue is absorbed. And last but not least, practice F. If I look at, I have green light coming into a magenta filter. Make sure that we realize that magenta is both red and blue, so R and B. And green light coming in, well, there's a problem there. There's a problem. I have green light, I have a magenta filter. Notice that these are complements on my color wheel. So no color is transmitted, and the color that is absorbed is green. No color transmitted, that means I would see it as black, where black is the lack of color.